Anyone know? You don't know? Okay, let me say something. If we will start from the beginning, so we will discover that we studied this year 3 types of functions, right? We studied, the first one was linear function, right? Where the second type, is there anyone can remember second type of function which we studied this year?
The quadratic function.
Yes, the quadratic function, right? And this year we will add the third one, which is exponential function. Exponential function, it's one from the functions which is very important in our real life. So sometimes when you are going to deposit money in a bank for a while and you want to know your profit after a time, so you have to use exponential function. If you will take a loan from the bank, bacteria, scientists use exponential function. They studied properties of bacteria. I think you studied something like that in science, but we are going to study it in math way. Okay, so let me revise with you first how we can find the difference between the 3 types of functions. Did you remember a linear function? The highest exponent is what? Or give me any example about linear function. Give me any example about linear function. So I can say, for example, y equal, or we can function, so we can say f of x equal x plus y. So this is a linear function, right? Because the exponent here is how many? The highest exponent is what? The highest exponent, if you have f of x equal x plus y or x plus 2, whatever, x plus 2, for example. So the exponent here is 1, okay? So the exponent is 1, so we can say that this is called a linear function. Anyone can give me an example about quadratic function? The highest exponent is what?
F of x power of 2.
X to the power of 2, right? So we can say x to the power of 2 plus 2. So this is quadratic function. But today with exponential function, so it will be f of x equal 2 to the power of x. So we can note that the independent value, which is x, we have it here as an exponent, right? So you can note that x here is a power, is an exponent, is not as a base. So before we will start to go through our lesson today, we have to know the difference between 3 types of functions which we studied this year. So the first type, again, it was linear function, and we can see the exponent for x is 1, and here we have the independent value, which is x as a base. Quadratic function, so we have x to the power of 2, and also we have x as a base. And third one is exponential function, and we have exponent here as a variable x. Also, sometimes we have a table and we want to determine the type of function. So we can note here in the 3 examples in front of you that we have linear function, quadratic function, and exponential function. With linear function, we have x and y. So we have independent value and we have the dependent value, or the input and the output. So what do you note in the first table, grade 9? What do you notice in the first table? The value of x was 1, 2, 3, 4, 5, right? So we have a common difference every time. So 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1. And you can note that in the three examples, we have the same 1, 2, 3, 4. So we have with x values, we have a constant difference. But we want to find the difference from the first one to the second one. What do you note grade 9, please? -5 to be -3. What happened? Grade 9. Every time we add 2. Right? Then -5 plus 2 equal -3. -3 plus 2 equal -1. And -1 plus 2 equal 1. And 1 plus 2 equal 3. So we can note here that we have a constant first difference. So once we have a constant first difference, so we can call this one is what? Linear function. So this is called what again, grade 9?
Linear function.
Linear function, when we have a constant first difference. The second one, look at the difference in y-axis. 6 becomes 12, so we add 6. 12 becomes 20, so we add 8. 20 becomes 30, so we add 10. Do we have a constant difference here? It's 6 and then,
No.
then 10. Do we have a common difference?
No.
No. But we are going to use the second difference. Then 6 plus 2 becomes 8. 8 plus 2 equals 10. Then we note that we have a constant second difference. So once we have a constant second difference, so we can call the function is a quadratic function. Okay? Then in the first type of function and second type of function, we are looking for a constant difference. But every time we are going to add. But look at the third one. Yesterday, we talked about geometric sequences. And we said geometric sequences, we multiply every time by the same number. So here in this one, we have 6 becomes 18, 18 becomes 54, 54 becomes 162. Do we have a difference between the y coordinates here? We have a difference. We can find the difference between each one and the next. Do we have difference? Tell me yes or no. Could you please unmute to
Yes.
join me? Do you have a difference between 6 and 18? Yani we can say 18 minus 6. We can mix them.
Yes.
No.
Okay, if you would say 18 minus 6, it will be how many? 18 minus 6, it will be how many?
12.
It will
12.
be 12. Yes. Okay, 54 minus 18. It will be?
1 minute.
It will be
yes.
36, right? Okay. If you will try to find the second difference, you can't find a constant difference in this table. Okay, so we will move to the second option. We will try to divide 18 like the geometric sequences. 18 divided by 6 equal how many?
3.
Well, 3, yes. And after that, we will make 54. 54 divided by 18. It will be how many?
3.
3. And 162 divided by 54. It will be equal 3. Right? Then to move from one y coordinates to the next, we multiply by 3, multiplied by 3, multiplied by 3. And this is called what? This is called constant ratio. Then with exponential function, don't have constant difference, but they do have constant ratios, right? So this is the third type of functions, okay? So before we will go through the questions which related to exponential function, we have to know the difference between three types of functions. So the first type of function, we said that it's what? The first one, it's what? It's linear function. And we note that with the linear function we have, with the linear function, we have first difference, right? With the quadratic function, we have
Second difference.
second difference. And with exponential function, we have
Constant ratio.
constant ratio. And understood what the meaning of constant ratio? Understood what the meaning of constant ratio?
Yes.
Okay.
Y values are multiplied by constant amount.
Y values multiplied by the same
Constant
number
amount.
every time, right? The same number every time. Okay. Now we will move to our lesson today, which is talking about exponential function. So with exponential function, the vocabulary which we have today is what? Exponential function. And we understood how we can say this one is an exponential function. If we have a table like this, the table and the graph show an insect population that increases over time. Then, the days here, the time by days, and the population. So we have 0 at the beginning, it was 2, 1 day, it's 6, 2 days, 18, 3 days, it's 54. If this one represents exponential function, if this one represents exponential function,
Yes.
yes. From where we know, we will check the difference between or the y coordinates. Then 2 multiplied by 3 becomes 6. 6 multiplied by 3 becomes 18. 18 times 3 equal 54. So this one represents an exponential function. If I want to graph, then did you see the graph? It's like a curve, right? Then 0 and 2, 1 and 6, 2 and 18, and then 3 and 54. Then a function rule that describe the pattern above is f of x equal, this relation in exponential form, then we have to care about A1. Which one is A1 here in this question? Which one is A1? What is the first number in this pattern?
2.
2, right? And what is the difference in this pattern?
3.
3. Okay, then if we want to write this equation in exponential function, so we will write it like this. A function rule that describes the pattern above is f of x equal 2 times 3 to the power of x. What's 2 donate for? 2 was
Starting population.
the starting population, and 3 the amount of which the population is multiplied each day. So once we have exponential function and I want to write it in a rule, so we will write 2 times, and 2 represent the starting point, so we can say that the formula which we have to use it to express an exponential function has the form f of x equal a p power of x. A not equal 0, so it's impossible to substitute the value of a by 0. Like the starting value, it will never be 0. And b, it's not equal 1. B should be more than 0. Let me give you an example. The function f of x equal 500 times 1.035 all to the power of x models the amount of money in a certificate of deposit after x years. Okay, so this function represents what? This function in front of us represent what? Models what?
Amount of money in a certificate.
Yes, the amount of money in certificate of deposit after X years. Then you want to deposit the money in a bank, right? And you want to leave it for a while. Then how much money will there be in 6 years? So we will replace the value of X now by how many to solve this question?
6.
We will, yes, we will substitute the value of X here by 6 to find the amount of money after 6 years. Then we will write the function first, which is f of x equal 500 times 1.035 all to the power of x. Second, we will substitute x for 6 for x, and then we will find and we will evaluate 1.035 all to the power of 6, and then we will multiply it by 500. So by the end, there will be $614.63 in 6 years. Another example. Could you please try to solve it by yourself and tell me the answer? I'm waiting for the first one will say the right answer. Quickly. He gave us the function, and he said, and this one where x is the time in years. Laura, are you ready?
Yes.
Yes, could you please tell me the answer?
The answer is 173,625.1.
Agree with her about this number?
Yes.
Agree with her? Yes. How did you solve it here, Laura?
For the x, I put 7.
Yes, for the x, you put 7 because we will substitute the value of x because he said already that x is the time in years and we want to calculate it after 7 years. In this question, this is models for the width of the photograph in inches after it has been reduced by 25% x times. What is the width of the photograph after it has been reduced 3 times? Then he said here that the value of x represent what? The value of x times, right? This is the number of times. Then we will substitute the value by 3. So we can find word problems like this in exponential function. And don't forget, remember that the linear function have a constant first differences, quadratic functions have a constant second differences. Exponential functions don't have constant differences, but they do have constant ratios. Okay? As the x values increases by the constant value, as you see here in this table, so we can see that 1, 1, 1, so the constant amount, but the y values are multiplied by a constant amount. This amount constant ratio and is the value of b. We have to use this formula to deal with exponential function. So we have a general formula, which is f of x equal a p to the power of x. Could you please tell whether each set of ordered pairs satisfy all the exponential function? Tell me this one, which in front of you now, if this one represents exponential function or not. Debulina. Dubulina,
Yes, miss.
this group of order pair represent exponential function or not? How do you know that this one represent exponential function?
Because the constant ratio is 3,
How did you find it?
I divided 12 over 4
Yes, very good. And
and
then
36 over 12
very good. And then
and 108 over 36.
thank you so much. Agree with her, Farah? Farah, agree about
Yes.
what Dibulina said? Yes. Then to describe or to say whether this set of order pairs satisfy an exponential function, we have to do what, ya Farah? How we would say that this one exponential function?
We're gonna divide the numbers by each other to find the constant value.
The constant ratio, right? What about if we can't find a constant ratio? So this one, it will not be an
An
exponential
exponential function.
function, okay? Then we can draw them in this table, and then we will find the constant ratio that every time we multiply it by 3. If I want to write a function related to this relation, is there anyone can help me to know how we can write a function related to this relation, this bunch of set of order pair? How we can write the function? How we can write the function which related to this one? F of x, it will be what? What is the general form?
A times b power of x.
Okay, so it's a times b to the power of x. Then you know, Yasama, how we can write the function now? What's a donated for?
No, I don't know how.
Okay, a, this is represent the first number, the starting value.
Okay.
Right? So it will be equal 4.
4.
After that, b represent the constant ratio every time. So the constant ratio here was 3, right? All to the power of x. So if you want to write a function related to this bunch of order pair, so it will be a b to the power of x. And we said that a starting value, b the ratio, the constant ratio every time, all to the power of x. Understood?
Yes.
Let's move to next question. Abdullah? Abdullah?
Yes, miss.
Good morning.
Morning.
Do you know how we can say that this one represents exponential function or not? Abdullah? You attend the session from the beginning, Abdullah. You didn't got anything? Crash? Crash?
Yes, ma'am.
Could you please tell me how we can solve this question?
Miss, I had a question.
Yes.
For this way,
Mhm.
we can also add the digit to get the next number, or is it not possible?
No. Add, this is in linear or a quadratic function. Okay?
So we can.
Yeah, no, we can't. We can't. With exponential function, we have to search about a constant ratio. And how you will find the constant ratio? You will divide the number like the previous example. 12 divided by 4 equals 3. So in this example in front of you now, Krish, we can say that this bunch of order pairs represent exponential function or not.
We have to see if it's divisible or no first.
Yes. Yes.
So here, everything could be divided by 64 can be divided by 2, and the other one 2.
No. Please concentrate and I will back to you again, Krish, please.
Okay.
Okay, Salma. Salma.
Yes, miss.
Hello, Salma.
Yes, miss.
Good morning, honey.
Good morning.
Could you please tell me this group of order pair represent exponential function or not?
It does not represent exponential
Yes, yes. Why? Why?
function
Why?
because it does not have constant ratio.
Because it doesn't have a constant ratio. If you would try to find 0 divided by negative 64, it will be equal how many? It will be equal 0, right? 64 divided by 0, meaning less. So we can't find a constant ratio between the y in the y coordinates, right? But we will find that we will add 64, add 64, add 64. But this one now represents the question set. Tell whether each set of order pairs satisfy an exponential function. So your decision now that this one, it will be exponential function, you told me no, right? But this one, it will represent what? Represent
Linear
what?
function.
Linear function. Thank you, because we found from the first difference. Thank you, Yasalmi. So this one, this is not exponential function. As the x values increase by the constant amount, the y values are not multiplied by a constant amount, so it's not exponential function. But as we explained before, we can say that this one, it will be a linear function. He didn't want to mention the type, but this is just to review your information about this part. This is another question. It has the same idea. This one, it will be exponential function or not. So we will say yes or no. This one now, it will be exponential function. No, this one, it will not be exponential function. And what about the next one, the last one here? Is this one exponential function?
Yes.
Yes, it will be a constant. So we have a constant. So this one, it will be exponential function. Let's move to the next part to graph exponential functions. We will choose several values for positive or negative and 0 and generate order pair, plot the points, and then connect them with its most curve. So it's normal like a graph. We will just find an order pair and then we will substitute the value of x to find the value of y, and then we will draw the coordinates. So graphing y equal a b to the power of x with a more than 0, as I said, we can't say that a it will be 0 and b more than 1. Then this is the first example, y equal 0.5 times 2 to the power of x. So you can use a table to find the order pair, or you can use your calculator. So it's up to you the way in which you are going to find order pair to satisfy this equation, and then we will start to graph it. So we will choose several values of x and generate order pairs. Like this one, you can suppose that the value of x equal negative 1, 0, 1, whatever. So the table, it will be like this. And then we will start to draw the graph. You can notice here that this graph, it will be like a curve, like a curve. Did you remember before when we talk about linear, it was a line, a quadratic function, it looks like a letter U, but here in exponential function, it will be like a smooth curve like this, okay? Another question, y equal 2 to the power of x, we will use the same way, okay? 2 to the power of x, then and we will represent it graphically. So the answer, it will be like this, y equal 2 to the power of x. What is the y-intercept in this question? What is the y-intercept in this question?
1.
1, yes. So the y-intercept in this question, it will be equal 1. And 2 is positive number, right? So we can note that the curve it's point to the right side. Did you see? It's point to the right side. So the base is positive number. So we can say that this one is point to the right side. If the first number is less than 1 and 5 is positive, greater than 1, so this one, it will be something like growth and decay, and this is what we are going to talk about it later on next session, inshallah, exponential growth and decay. But in our lesson, we want only to know how we can graph this exponential function and how we can find just an order pair. Now we can note that the value of a here is more than 0 or less than 0. The value of a here in this question, the value of a
less than 0.
less than 0. It's negative number, right? So I want you to note now what happened to the graph. Do you see the graph?
It goes down.
It goes down, right? Okay, so if the value of a is less than 0 and b is more than 1, so we will note that the graph it will goes down. Okay, then we have another question like y equal negative 6 to the power of x. By the same way, we will find the order pair and then we will represent it graphically, and you can note also that the graph it will goes down because the value of a equal how many is a negative number or less than 0. The same, what do you expect about the graph in this one? What do you expect about the graph?
Will be downward.
It will be downward. Thank you. It will be like this. Okay, what do you expect about this one? It will be downward and it comes from this side. Did you see? Because the value of b here also is less than 1. So the value of a is less than 1 and the value of b is less than 1. So did you see the graph? It goes down, but it will come from the right side to, then it will move down. Here in this one, I have 4, which is positive. 0.6 is less than 1. So you will see how the graph it will looks like. So the graph, it will be like this. Okay, and so on. We have different examples about how we can represent them graphically. Then today we were talking about exponential function, right?